Let's start from the point that this square depicts people's thinking. A significant part of that shape includes mathematical thinking, which is a process that everybody does intentionally or not. The key question that every teacher must answer is, which are the elements of mathematical thinking? If teachers give an answer to this question, then the processes they should cultivate to their students might be clearer. In order to answer the aforementioned question briefly, I would say that some typical parts of mathematical thinking are analytical and systematic thinking, deductive and inductive reasoning, and critical thinking. All these processes under discussion are invisible, since such functions are taking place inside our brain, and it is impossible to get inside. What we do have access to is the outcome of mathematical thinking, the mathematical understanding. My next question is, what does it mean that students have mathematical understanding? The answer should be considered upon two principles: conceptual and procedural understanding. The first concept refers to learning mathematics with understanding and gaining benefits of actively building connections between new and prior concepts. What is more, conceptual understanding means deep and strong knowledge and is related to constructing webs of knowledge. On the other hand, procedural understanding is connected with memorizing a specific order of doing something, for example, multiplying. But students cannot answer the question, how does something happen in a particular way? The follow-up question is how we can make mathematical understanding visible. The answer is students' discourse. That is the means which reflects students' mathematical understanding and their way of organizing their thinking and reasoning. Mathematical discourse consists of three crucial processes: mathematical argumentation, mathematical justification, and mathematical explanation. Mathematical argumentation is how somebody organizes logical arguments in order to support a theory, an action, or an idea. Mathematical justification is the process of giving reasons to prove your opinion. And last but not least, mathematical explanation is the fact that you provide causal relationship between two situations. All these processes are valuable since they lead to mathematical proof in secondary education, which is the most powerful mathematical tool for determining the true value of a statement. To sum up, and in order to answer to those wondering how to apply such things in the classroom, I have to say that two things are crucial. First, to find an appropriate way to spot the aforesaid processes in students' discourse, since they enable teachers to gain insight into pupils' mathematical understanding. And second, to manage to incorporate mathematical argumentation, mathematical justification, and mathematical explanation into the teaching and learning process. No matter what mathematical idea you are teaching, those processes are always there. So, highlight them and work on them with your students.